16. Why is it all right to choose a system for which static friction occurs at the system boundary, but a bad idea to do so for kinetic friction? Remember the argument we had in the previous chapters that if you've got, say, an object on the floor like that, it was highly recommended to not draw your system on the boundary like that, because if there is friction between the two, if it was sliding and there was kinetic friction, then that kinetic friction would cause heat to be dissipated into this block and into the surface. And so it was not possible, very difficult, to determine how the energy change inside your system. Okay, so this was when we had kinetic friction. Okay, so that's why it's a bad idea to do that for kinetic friction. But for static friction, these two surfaces are not sliding relative to each other, so there's no heating up of the surfaces. There's no thermal dissipation, thermal energy increased inside these surfaces. So it is okay to put the system boundary there for static friction. Okay, static friction, it's a reversible process, so we don't heat up those surfaces. Okay, hope that makes sense. Describe one case in which a force of static friction does no work, and one case in which a force of static friction does work. Okay, so remember, work was force times displacement. So there has, in order for there to be work done, there has to be a displacement of the application point of the force. So if a force is applied to that point, if that point displaces, then that force has done work. If that point does not displace, then what? Then there's a force there, but there's no work is done by that force. Okay? So, this is chapter 10. So what are some examples there? Okay, so one example of this, I think this does come from an earlier part of the textbook. If your foot is on the floor, right, and your foot wants to move that way, the friction force is being applied that way, and you are walking that way. Does that friction force there do work? Right, there's your other foot. There you're walking, so you are actually moving in that direction. There's a static friction force there. Does that force do work? No, it doesn't, because this point, there's no delta x over here. No, there's no delta x there. So what causes the motion of your body is energy inside your muscles. Okay, so that's a chemical energy, that's source energy, but the force does not do any work. Okay, let's see the example they give in the textbook. Another example of this is a wheel of a car. Okay, and so now the wheel is turning that way, and so in order for it not to slip, we need a friction force that way to counteract that. But the question is, does that force do work? does that force do work? Well, the car ends up moving that way, but that point, okay, that point over there does not displace. Okay, so that force does not do any work. Okay, but an example of where you can do work is, say now you're carrying your cell phone on your hand. Okay, so just imagine there's your fingers, and there's your, I don't know, your thumb. Okay, and you're walking that way. So you're carrying it with your open palm, and your cell phone is on your palm. Okay, now there's a static friction force there. Okay, and in this case there's the application point and it moves. So as you carry as your palm moves, that you got your delta x there, and so in that case the static friction force does actually do work because there is a delta x. Okay, then also just look at the review questions, the solutions. Explain what is wrong with this statement. The force of friction always opposes motion. It always opposes motion. So we somehow come up with this idea is like, if you have an object that wants to slide down there due to gravity, so it wants to move in that direction, so you're going to have a friction force there at the surface there, static friction or kinetic friction, and it wants to oppose that motion. Well, that's true, okay, but the friction force doesn't always oppose motion. It always opposes relative motion between these two. Okay, so it always opposes relative motion. So an example of where it doesn't oppose the motion is if you're the example they give in the textbook, if you're on a conveyor belt, okay, and the conveyor belt is moving in that direction, and there's static friction here. There's the static friction force, and it's pointed in the same direction as the motion of that object. Okay, so it does oppose the relative motion, but it doesn't necessarily oppose the motion of the object. Okay, so please make sure you get that. Cheers.